Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 8, Lesson 2. Today we are going to continue our discussion of simplifying radical expressions, but now we're going to throw some variables into the mix. So let's just review from yesterday. When we are simplifying variables, we want to make sure that we pull out pairs of common factors. This theory is the same as when we're working with variables. So remember that x squared is the same thing as x times x. This x times x is a pair of variables. So that x times x underneath the radical is going to make one factor of x outside of the radical. So the best way to find the pair is to write out the number of letters that you have. That's what we're going to do, just like we did with our factors yesterday. We're going to write out the number of variables we have of each type of variable. And then we're going to look for those factor pairs that we can pull out from under the radical. All right, so let's take a look at x to the fifth. So x to the fifth is the same thing as 5 factors of x. So x times x times x times x times x. That is technically the prime factorization of x to the fifth. If I broke that apart or expanded it out, I'd have 5 factors of x. Once I have those 5 factors of x written out, now I'm just looking for pairs. So there's one pair that makes one outside. There's another pair that makes one outside. This one is left over, but it does not have a pair, so it has to stay underneath. Then I can remind myself that x times x is x squared. So I have x squared times the square root of x for this x to the fifth. So that's after I've taken all of the perfect square factors out of that x to the fifth, because x times x is technically a perfect square. Let's take a look at number 2. Now I have 6 factors of x. 1, 2, 3, 4, 5, 6. So now when I put those under the radical, I have this factor pair of x's, I have this factor pair of x's, and I have that factor pair of x's. That x times x times x is the same thing as x to the third. I took everything out from under the radical. There's nothing left over, so that's my only answer. There's no more radical piece to that expression. In number 3, I have x to the 8th. So I have 8 factors of x. 4, 5, 6, 7, 8. So that's what's underneath my radical, and then I'll look for those pairs. There's 1, 2, 3, 4 pairs of x's that can all come outside of the radical. And there's no x's left over underneath, so there's no radical left. That's simply x to the 4th. I want you to start to pay attention to the relationship between the exponent that was underneath the radical expression and the exponent that is out of the radical expression when we're finished. So I had 8 x's underneath, and after I was done simplifying, I had 4 x's outside. So, watch for a pattern there. Let's take a look at number 4. I have x to the 13th. So if I line up 13 x's in a row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my 13 x's, okay? Let's see how many pairs I can make. I can make 1, 2, 3, 4, 5, 6, and I have 1 left over. So x to the 6th power with 1 x left over is what I have there. Now, again, I want you to look at the relationship between the x's that you had underneath and the x's you have outside, okay? I can't take 13 and divide it by 2, but if I take 12 divided by 2, I get 6, and then I have 1 left over underneath. So that's what's happening here. When I take 8 and divide it by 2, I end up with 4 pairs outside. When I take 13 and divide it by 2, I have 6 pairs outside with 1 left over. So that's another thing that you can recognize. Anytime you have an even number of factors of a variable underneath your radical, you're going to have no leftovers underneath. If you have an odd number, you're going to have 1 left over because you'll have that one odd one out that can't find a pair. Let's take a look at the next one. Now we've got 2 variables to look at. So I've got 4 factors of x, and I've got 7 factors of y. These are all being multiplied together under the same radical. So for my factors of x, I can make 2 pairs. So that's x times x. For my factors of y, I can make 1, 2, 3 pairs with 1 left over. So I have a y, and a y, and then I have that radical y still left over. So if I put all this back together, that gives me x squared times y to the third with a radical y left over. Let's take a look at number 6, r to the 5th and s to the 7th. So if I split these up, I have 1, 2, 3, 4, 5 r's and 1, 2, 3, 4, 5, 6, 7 s's. Those are all of the factors I have underneath that radical. Now let's make some pairs. Here's 1, 2 pairs of r with 1 left over, and 1, 2, 3 pairs of s's with an s left over. So underneath my radical, I have an r and an s. So outside, that leaves me with r squared times s to the third, and underneath, that leaves me with an r and an s. So that's my simplified expression. Now, you're probably thinking it doesn't look any simpler than the one we started with, except for the fact that mathematically it is, because mathematically we removed the perfect squares from underneath the radical, and that is the definition of simplifying the radical. Take those perfect squares out from underneath the radical. You can't leave them in there. Let's take a look at number 7. Now we're going to put some numbers together along with the variables. So we just do the same thing that we did yesterday and combine it with what we're doing today. So break down that 24. That's the same thing as 4 times 6. 4 is 2 and 2. 6 is 2 and 3. And then the x to the third is x, x, x. So I've got that all together. And then my pairs are 2 and x's. So I've got a 2 out front and an x out front. Underneath, I have 2 times 3, which is 6, with an x left over. So 2x root 6x. That's what that whole thing breaks down into. Let's look at that 50 times r to the 5th. So 50 times r to the 5th. 50 is the same thing as 5 times 10, and that's 5 times 5 times 2. And then that r to the 5th is r, 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 and r. Okay. So now let's look for our pairs. I got a pair of 5s, I got a pair of r's, and another pair of r's. So 5 times r, with a 2 and an r left. That's 5r squared, square root 2r. All right, 18a to the 6th. So 18 is the same thing as 9 times 2. That's a 3 times 3 with a 2 left over. And then I got 6 factors of a. 1, 2, 3, 4, 5, 6. Put them underneath your radical. Here's a pair of 3s. Here, the 2 is by itself, so I got to leave that one. A pair of a's, a pair of a's, and a pair of a's. A times a. Leave the 2. That's 3a to the 3rd power, square root of 2. 75 times q to the 4th. I end up here with 25 times 3. That's 5 times 5 times 3. And then q to the 4th is 1, 2, 3, 4 q's. Here's my radical. Here's a pair, here's a pair, here's a pair. So I've got a 5, a q, and a q. 3 is by itself. That's 5q squared, square root of 3. Number 11, 81 times w to the 3rd. So 81 is nice because it itself is a perfect square. I've got a 9 times a 9, and then this a w, w, w. Now, I didn't go all the way down to the 3 and the 3 and the 3 and the 3 because I recognize that a 9 times 9 is a pair. So if this were my radical, I'd bring that 9 out front. If you didn't recognize that, you would have gone down to 3, 3, and then 3 and 3, and you'd bring out a pair of 3s and another pair of 3s, and 3 times 3 gives you that 9. So you end up with the same result. Basically, you're just recognizing 81 itself is a perfect square, and its square root is 9. So I have 9w square root w. 36d to the ninth, same thing here. I recognize that 36 is 6 times 6. So then I have 9 d's, 2, 3, 4, 5, 6, 7, 8, 9 underneath my radical. So my pair of 6s can come out. And again, I didn't go down to the 2 and the 3 and the 2 and the 3. All that would have done was give me a pair of 2s and a pair of 3s. 2s come out, 3s come out, 2 times 3 gives me 6. So still, in essence, I'm getting a 6 out front. Now, if I think about the 9 d's, I can make 4 pairs and I should have 1 left over. So 1, 2, 3, 4, there they are, d to the 4th with 1 d left over. Let's talk about 100u to the 4th. Ooh, check this out. This is going to be a good one. 100 is the same thing as 10 times 10. U to the 4th is u times u times u times u. And look at everything that comes out. You got a pair of 10s, you got a pair of u's and another pair of u's. And you've canceled everything under that radical. So I have a u out front, another u out front, nothing left underneath the radical. That's 10u squared. Same thing in 14. 64 is the same thing as 8 times 8. X to the 8th is going to be x to the 4th out front. If I line up my 8 x's, I have 1, 2, 3, 4 pairs. And that just comes from the fact that 8 divided by 2 is 4. So you get 4 factor pairs there. This pair of 8s also comes out front. That was a bad arrow, sorry. So I have 8 x to the 4th and nothing left under the radical. I took everything out. Okay, last two. 126 to my knowledge is not a perfect square. I do see that it's even though, so let's see what it is when we divide it by 2. So 126 divided by 2 is 2 times 63. 63 is the same thing as 7 times 9. So I end up with a 2 and then a 7 and a 9. That 2 comes down, that 7 comes down, 9 is 3 times 3. All right, so there's my prime factorization of 126. Then I've got all the variables. So 1, 2, 3, 4 x's and 1, 2, 3 y's. So if I put those under the radical, what pairs can I take out? 2 is by itself, I have to leave it. 7's by itself, I have to leave it. Here's a pair of 3's. That can come out front. Here's a pair of x's. That can come out front. Here's another pair of x's. That can come out front. Here's a pair of y's. That can come out front. This y is by itself. I have to leave it. So underneath I have the 2, the 7, and one more y. So now let's put it all back together. So 3 times x times y is 3x squared y. And then underneath 2 times 7 is 14y. All right. Let's take a look at 48p to the 3rd q to the 8th. So 48 is the same thing as 6 times 8. This is 2 times 3. This is 2 times 4. I need to break down that 4. Some people get kind of lazy, for lack of a better word, and they don't want to drag these factors down right here. When I have the 2 that can't be broken apart and the 3 that can't be broken apart and the 2 that can't be broken apart, they don't want to bring these down. I'm going to highly recommend that you bring those down to that bottom row because it's really nice to just be able to say, yep, there's my radical. If you don't carry all of those down, then you might drop some factors up above and unintentionally without meaning to. Then I have 1, 2, 3 p's and 1, 2, 3, 4, 5, 6, 7, 8 q's. There's my radical. Here's my pairs. So I've got a pair of 2's here. They're not next to each other, but it still counts as a pair. I have a pair of 2's there. My 3 is left underneath. So I've got one set of 2's, another set of 2's. Now I've got a pair of p's. This p is by itself. And I have 1, 2, 3, 4 pairs of q's. Underneath the radical, I have that 3 left over and a p left over. So let's put it all back together. This gives me 4p q to the 4th square root 3p. All right, that takes us to the end of our notes for today. Thanks for tuning in, and I will catch you next time.